From there, validating sources and restricting purchases to approved distributors reduce the risk of counterfeit or compromised parts entering inventory. Approved distributors are vendors that meet defined security and quality requirements, such as verification of manufacturer authorization and secure storage practices. Unauthorized resellers, even if cheaper, often bypass controls that guarantee authenticity. For instance, a network equipment supplier might allow purchases only through vetted partners whose chains can be audited. Source validation checks supplier certifications and purchase documentation, ensuring that only legitimate components enter production. This control transforms procurement from a cost decision into a security safeguard. From there, tamper-evident packaging and seals add a physical layer of protection. These mechanisms make unauthorized access visible, signaling that a component may have been compromised before installation. Packaging might use holographic seals, serialized tape, or color-changing adhesives that cannot be reapplied once opened. For instance, a shipment of encrypted drives may arrive with seal numbers matching those listed in the packing manifest. If any seal appears broken or mismatched, the shipment can be quarantined for inspection. Simple visual cues like these deter tampering attempts and provide immediate grounds for verification before acceptance into inventory. Building further, serialization, lot tracking, and detailed records provide continuity and traceability throughout the product's life. Each part should carry a unique serial number or belong to a tracked production lot recorded in an immutable log. Lot tracking connects manufacturing data, such as plant location, date, and quality checks, to each distributed unit. For example, if a batch of power supplies is found defective, serialization allows rapid identification of affected systems and targeted recalls. This traceability also assists in warranty validation and regulatory reporting. A robust serialization system ensures that no component's journey disappears into anonymity. From there, enforcing secure manufacturing and handling standards prevents tampering before components even leave production sites. Secure manufacturing includes background checks for employees, controlled facility access, video surveillance, and protected storage areas. Handling standards require packaging integrity and controlled shipping conditions to prevent substitution during transit. For instance, a certified manufacturing facility might limit component access to cleared personnel and log every withdrawal from secure bins. These operational safeguards ensure that authenticity controls begin at the source, reducing opportunities for interference at any later stage in the supply chain. Building on that production discipline, incoming inspection and verification testing act as the first defensive checkpoint after receipt. These inspections can include visual review, serial number validation, electrical testing, or cryptographic verification depending on the component type. For example, a quality assurance team might verify digital certificates embedded in devices or perform sample testing for physical anomalies. This incoming verification confirms that components match purchase records and manufacturer specifications before integration. Detecting authenticity issues at this stage prevents counterfeit or compromised parts from entering operational systems where detection becomes far more difficult and costly. From there, secure controls must also govern return, repair, and RMA processes. Returned materials present opportunities for substitution, especially if defective or damaged components leave the organization temporarily. Repair centers must verify identities, maintain tamper logs, and ensure that returned units come back from authorized service providers only. For example, before accepting repaired routers, the organization might validate serial numbers against the original shipment and confirm recertification by the manufacturer. Without strict return management, counterfeit parts can re-enter inventory disguised as replacements. Secure RMA processes preserve the authenticity chain even when components leave normal custody. Building upon that vigilance, organizations must detect substitution attempts and prevent gray market leakage. Substitution occurs when unauthorized parts are inserted during transit or assembly. Gray market leakage arises when components intended for one region or contract are diverted elsewhere. Detection measures include serial number audits, supplier declarations, and anomaly detection in procurement data. For instance, if shipment records show a part shipped twice with identical identifiers, the system flags potential duplication or fraud. Monitoring for such irregularities ensures that counterfeit channels cannot exploit oversight gaps. Vigilance against substitution preserves not only product quality, but also regulatory compliance and customer trust. From there, supplier attestations and audit rights reinforce mutual accountability. Suppliers should regularly attest to the authenticity of materials they deliver and agree to external audits that verify those claims. These attestations include signed statements or digital certificates confirming that supplied parts originate from approved sources and comply with authenticity requirements. Audit rights allow customers to inspect supplier processes, test samples, and review traceability records. For example, a defense contractor might require quarterly authenticity attestations plus the right to inspect manufacturing lines annually. This shared oversight builds cooperative transparency, turning the supplier relationship into a trusted verification network. Building on that shared responsibility, exceptions, such as purchasing through non-standard channels or accepting components without full verification, must be handled with heightened monitoring and documentation. Temporary deviations should be explicitly approved, recorded with justification, and subject to additional scrutiny. For example, during supply shortages, an organization might purchase from an alternate distributor but perform expanded inspection and extended testing. Heightened monitoring prevents convenience-driven decisions from eroding long-term control integrity. Exceptions are inevitable in global supply chains, but disciplined handling ensures they remain controlled, visible, and temporary rather than habitual. From there, metrics such as authenticity failures, detection rates, and exposure timeframes provide quantitative insight into control performance. Authenticity failures count how often counterfeit or tampered components are discovered. Detection rate measures how quickly issues are identified. Exposure timeframe tracks how long unauthorized components remained active before removal. For instance, reducing exposure from weeks to days demonstrates stronger detection capability. Metrics convert authenticity assurance from a qualitative claim into measurable effectiveness, guiding process improvement and supplier accountability. Transparent performance data promotes continual refinement and motivates suppliers to uphold high standards consistently. In closing, trustworthy parts form the foundation of trustworthy systems. The SR-11 control underscores that authenticity is not just a manufacturing detail. It is a security requirement central to maintaining integrity across every layer of the supply chain. By enforcing chain of custody, validating sources, verifying cryptographic identities, and tracking exceptions, organizations ensure that every component entering their environment is genuine and verifiable. When authenticity becomes routine rather than reactive, systems inherit not just function but confidence. The result is a resilient infrastructure built on components whose origin and integrity are beyond question. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.